In this topic, we'll focus on making your HSM integrations production ready. You'll design tests that really prove security features work, quickly isolate where failures come from, and apply structured troubleshooting so your applications and teams can handle real-world incidents with confidence. You've built up a complete HSM storyline. First, you learned the architecture and how clients securely connect and authenticate. Then you focused on keys, how they're created, managed, and exposed through PKCS number 11 and higher-level APIs. You mapped those into real applications and operational use cases, like TLS, PKI, and code signing. Now you're ready for the final step: systematically testing, debugging, and hardening all of that before it ever reaches production. Moving from a local crypto library to a Luna-backed design means you're no longer testing just code. You're testing behavior across middleware, client configuration, network trust, HSM partitions, and key policies. A failure might come from your business logic or from a misconfigured mechanism or partition. That's why mocks alone aren't enough, and why a layered testing strategy becomes essential. Picture your HSM test strategy as a pyramid. At the base, you want lots of fast unit tests that use mocks or adapters, so you can iterate without touching a real HSM. In the middle, integration tests talk to a test partition through PKCS number 11 or JCE, proving that your code and the device agree. At the top, a small number of end-to-end tests validate real workflows, balancing speed, cost, realism, and security exposure. To make HSM-backed applications testable, treat cryptography as a service, not a scattered set of library calls. Your business code talks to interfaces like KeyStoreService or SigningService, and never sees sessions, slots, or mechanisms. In production, those interfaces are wired to the Luna client. In tests, dependency injection swaps in a mock or fake provider. Just make sure your abstraction still surfaces real-world errors like bad authentication, missing keys, or mechanism failures. Mocks, fakes, and real HSMs each answer different questions. Mocks ask, does my application call the API correctly and handle success, errors, and retries? Fakes ask, given fixed inputs, do I get repeatable cryptographic results for my logic tests? Only a real HSM answers, are policies, mechanisms, key permissions, and client configuration actually correct? Use the fast tools for feedback, but reserve your final confidence for tests that run on real hardware. Reliable HSM integration starts by treating every environment as configurable, not special. Keep all Luna client settings outside the binary. PKCS number 11 library path, partition labels, slot IDs, key labels, certificates, and credentials should all live in environment variables or a secrets manager. At startup, load these values, validate each one, and fail fast with clear, actionable messages. Use separate configuration profiles for dev, CI, test, staging, and production, so code stays identical even while environments differ. When you architect test partitions, you're trading isolation for efficiency. Shared partitions are cheaper and use capacity well, but they only give logical isolation. You'll need strict key naming, aggressive cleanup, and careful access control to avoid collisions and leaks. Dedicated partitions consume more licenses, but give full cryptographic isolation, simple reset-based cleanup, and much better support for high concurrency CI/CD pipelines. For HSM tests to be reliable, treat test keys with a controlled lifecycle. Create them with strict naming conventions, ideally tied to each CI run or environment. Keep a clear distinction between long-lived fixture keys and short-lived keys that tests create on the fly. Never reuse production keys, certificates, or live secrets. Finally, automate teardown. Delete temporary objects aggressively, while explicitly protecting shared fixtures from accidental cleanup. Think of your pipeline in two layers: fast feedback and slower, realistic validation. Every commit should run unit tests and mock-based crypto tests, so developers get quick signals without needing an HSM. Real HSM integration tests run less often on trusted branches, nightly builds, or as a gate before release. Protect all credentials in a secrets manager and design tests to fail safely and alert you if HSM access isn't available. For HSM integrated applications, observability should act like a smart filter. Capture rich context for every cryptographic call. Operation type, key label or alias, mechanism used, partition alias, plus a correlation ID that links app, client, and system logs. Layer on metrics like latency, failure, and retry rates and timeouts. At the same time, strictly exclude plaintext data, private keys, PINs, or any sensitive payload content from all logs. Most Luna errors fall into 4 buckets. Initialization issues usually mean something is wrong before the library even starts. Wrong conf file, missing library, or PKCS number 11 not initialized. Authentication errors point to PINs, logins, or certificate trust. Object or mechanism errors suggest a bad key handle, attributes, or an unsupported mechanism. Runtime or infrastructure errors hint at tokens offline, network problems, or exhausted sessions. Think of debugging as eliminating variables from the top down. Start by reliably reproducing the error with a tiny test and capturing the exact message, timestamp, and environment. Then confirm configuration. Environment variables, library paths, credential sources, partition or slot, and key labels. Next, run a minimal Luna PKCS number 11 or JCE diagnostic outside your app. Only after that decide whether the fault lives in your code, config, partition policy, network, or HSM infrastructure. Escalations go faster when you send an evidence packet, not just a complaint. Begin with exact error evidence, logs, correlation IDs, timestamps, and error codes. Add environment details like client, OS, and API versions, plus non-sensitive configuration notes. Prove connectivity with test tools or a minimal repro script. Then route it. App issues to developers, access or key problems to HSM admins, timeouts to network teams, and low-level faults to vendor or security teams. Reliable HSM integration doesn't happen by accident. Use layered tests to balance speed and realism. Design clean configuration seams, and follow a deliberate, repeatable debugging path. From here, apply these practices in a production readiness review and keep refining your team's monitoring and runbooks over time.